Hi Anna. Okay, I'm just going to give you a few of the answers to. Oh, I've lost my pen. Okay, there we are. I'm just going to give you a few of the answers you were asking for. So let's do question 10 first. Well, let's just rub out my scribble as well. Why can't I find anything tonight? Okay, this is being weird. Right, so let's start with question 10. All right, so the question is telling you that there's a ramp separating two different levels. So let's say there's a level up here and a level down here. There's obviously going to be a ramp that separates the two. All right, so this is going to be our triangle here. Clearly not a very good triangle. You get my point. Okay, so they tell us the ramp is 9.4 meters long and that there is 3.1 meters between the two ramps, between the height of the ramps, and they're asking you to find the angle that the ramp makes with the lower level. So they're asking you to find this one here. I think you just had a problem drawing the diagram. I probably don't need to do it for you, but obviously you're looking at sine theta equals 3.1 over 9.4, and you know what to do from there. Let's look at the next one. So the other two were slightly trickier. Although 15 is actually not that tricky. It's just about thinking about a 3D object in a 2D way. So they're telling you that there's a soft drink can, right? So if you look at a soft drink can front on, a soft drink can front on, it's really just looking like a big rectangle, isn't it? Then they're saying that a straw, so you've got a straw that fits diagonally on the soft drink can. And they're telling you that the soft drink can has a radius of 36 millimeters, so that's really halfway across here, isn't it? So the whole way across here, if it's 36 halfway across, it must be 72 all the way across, but let's change it to centimeters, because they've given us the straw in centimeters as well. So that's 15.7, I think they said, so 15.7 centimeters. You could do it all in millimeters if you like, it doesn't really make a difference. And then they're asking you to figure out what the height of the can would be. So, why have I lost my pen? I can't see it. Okay, there it goes. Okay, then they're asking you to find the height, so this is going to be an x. This is clearly a right angle. Now this looks like Pythagoras. So we've got a right angle triangle, we've got two sides and an unknown side. So let's say 15.7 squared, because that's the hypotenuse, isn't it? Equals 7.2 squared plus x squared. And you know what to do from there. Yeah, you understand Pythagoras, it's just probably having a problem drawing it. Hopefully that helps. Now the next one is actually quite tricky because it's a 3D problem. I'm going to change pen colours, maybe that'll help me see it. So this one is a lot trickier simply because you have you need to think in a 3D way. So we're not just thinking in a 2D way, the way that we have before. Even the 3D question before we could turn into a 2D problem. This one we can't. So bear with me while I draw it. I'm going to draw a north-south line and an east-west line as if that's paper. So think about this being like a flat thing on the ground. So this is your north line, okay? And then we actually need to talk about the height of a building. So picture this being in 3D. So I'm now going directly up from the ground, whereas these are on the ground. So this is like a horizontal plane, and I'm drawing directly up from the piece of paper, as in out of the screen. So we're saying that there's a height of a tower. So this is position K up here. The tower is 200 meters high. They're telling us that there is a position west, so X is somewhere, sorry, south, aren't they? Telling us that X is somewhere south. So this is north, this must be south. So we're going to come down from the top of the tower along our south line. This is going to be position X, and they're telling us that the angle here is 31. Then they're telling us there's another position over here, this is position Y, that is east, because this is our east direction. Once again, from the top of the tower out towards east, and this angle in here is 22 degrees. I hope you're able to understand what I'm talking about when I say 3D problem. So this is like a tower in the air, big building, and then we're on the street level here. We're going east on a street level, and we're going south on a street level, and this is up in the air in a 3D way. Now what they're asking us to do is tell us the true bearing of y to x. Now remember, north is always in the same direction. Stop doing that. So we can draw another north line coming out of here because we want north from position y. As long as it's parallel to where north is, that's fine. And we need to go across to position X, don't we? So we need to think about going across to position X. And we want from Y to X. So we actually want this angle in here. That's going to be our true bearing because we always start from north and go all the way around. Now you actually need to work out quite a few different things before you can work out this bearing, because you have no information at this point that's going to help you find that out. But given the height of the tower and these two angles, we can actually work out a couple of different things. So I'm going to change colours to show you the bits that I'm going to work on. So let's start with green. And we're firstly, oh, I've lost the pen again. Oh, there it is. Okay, we're firstly going to work out this triangle here, because we know the height of the tower and we know an angle, and we really want to know this bottom length here. So if I drew that, actually let's not draw it there, I need room to do some working out. Oh, sorry, I'm still a bit sick, I'm sniffing. Okay, so let's draw a little triangle here. So we've got our right angle down here. This angle here is 31 degrees and the height of our tower is 200 meters. Okay, up here is point K, over here is point X. That does not look like a K. Alright, so now what we want to do is we're going to find out this bottom length over here. Once again, I have lost my pen. Oh gosh. We want to find out this bottom length here because we're going to actually try and use this bottom triangle. So what do we need to do? Well, obviously we don't have the hypotenuse, which means we always need to use tan. So tan 31 equals opposite over adjacent, so the opposite side is 200 over the adjacent. Then we need to move the bottom of the fraction first. Then we need to get x on its own. And then, so all you do is type that into your calculator and you'll get 332.86. Alright, so that's clearly in meters, alright? So we found out this bottom length here, so we know this length here. So this is going to be our x we just found out. Let's have a go, let's pick a different colour. Let's pick blue, and we're going to work out this other triangle. So we're going to do this triangle here. Gosh, I am so not neat on this at all. And we'll call this one over here Y. We're going to find this bottom length, okay? So let's try and draw this triangle. So Y is going to be our bottom length. Our tower is still 200 meters, but we've got a different angle of elevation here. It's 22 degrees. So same thing, we still have our opposite and adjacent, so we're going to use tan again. So tan 22 equals opposite over adjacent. So Y tan 22 equals 200. Y equals 200 over tan 22, and if you type that into a calculator, you will end up with 495.02. So now we have a couple of different pieces of information that is going to help us. Let's change colour again. Let's go orange, why not? Alright, so now we're actually going to find this bottom triangle here, okay? So we're going to use this space to help us, because once we have this angle in here, we will be able to find this outside bearing. So let's think about what this triangle looks like. Okay, we figured out this one, this is Y, so this is 495.02. We figured out this one, this was X, so we had 332.86. And we need to find this angle in here. So once again, we'll use tan because we don't have a hypotenuse. So tan theta equals opposite, 332, whoa, that's not a 2, 286 over 495.02. And then remember, we just do the inverse if we're going to get rid of tan. So we inverse this, and you end up with 33 degrees, 0.92. Alright, now all we've gotten so far is this inside angle. We've got this little bit in here. We actually, let's change colour again, we actually want this whole outside bit. That's our bearing from north all the way around, from the point Y to the point X. So we know, let's draw some extra lines. So this is going to be our south line, our east line. Now we know north to south is already 180. And we know if we go all the way around to this west line, we're going to get 270. So essentially, we need to do 270 minus what we just found, don't we? Because that would be 3 quadrants worth, and we want to get rid of this little bit in here because that doesn't count. So if we do 270 minus 3392, that'll give us our true bearing. And if you type that into a calculator or you do it in your head, you get 236.08. So that is our true bearing from Y to X. I hope that made sense. If not, drop me another email and I'll have another go.